Good evening, Titans. This is Mr. Simpson, lesson 2.4, solving multi-step inequalities. All right, we'll get right after it here using two-step equations. And so again, we have two things being done to the variable. And so in this case, we're first going to get rid of the adding 7. So we're going to subtract 7 from each side. And when we do that, we're left with y over a negative 6 is less than a positive 2. And now, if you recall from the other day, when we were solving by multiplication and division, I have to multiply both sides by a negative 6. And remember, when I multiply by a negative 6, I have to remember to reverse that inequality sign. So my final answer is y is greater than a negative 12. And then again, if I were to graph this, negative 12 is there, surrounded by negative 13 and negative 11, open circle, and shaded to the right. Okay. Example 2, we're going to go ahead and add 4 to both sides first. And we get 2v is greater than or equal to 12. And now we divide by 2, and we get v is greater than or equal to 6. And we didn't have to worry about reversing the inequality sign there because we divided by a positive 2. And now we go ahead and graph that. We have 5, 6, and 7. Closed circle this time because it's greater than or equal to. And then again shaded to the right. Now we'd like you to try a couple of these. Number 3 must be, though, n over a negative 2 plus 11 is greater than 12. So go ahead and pause this and try a couple of these, and I'll reveal the answer to them. All right, welcome back. And number 1 should be b is less than 2. And again, it should be open circle at 2, shaded to the left on the graph. On number 2, our answer should be c is less than or equal to a positive 4. And here we had to make sure that we reverse that inequality sign because you had to divide by a negative 9 in order for you to solve this. On number 3, we would subtract the 11 first, and then again we'd have to multiply by a negative 2, which would have to reverse the sign. So our answer for number 3 would be n is less than a negative 2. And then number 4, again we'd subtract the 5, and we'd have to multiply by a negative 3, and so your answer to number 4 should be v is greater than a negative 3. Again, the graph for that one should be open circle at negative 3 and shaded to the right. And again, it doesn't look like this switch, but notice how the variable was on the right side, now it's on the left side. So we end up having to do a couple times moving that inequality around. All right, now we're going multi-step. So probably do this 2 different times and erase it. So first of all, letter A, we have 8b minus 3 is greater than 4 times quantity 2b plus 3. So the first thing we have to do is distribute. So I have 8b minus 3 is greater than 8b plus 12. And now we're going to go ahead, get rid of the variable terms from each side. Oops, when we do this, this variable term eliminates, and so does this one. They eliminate. And so I'm left with a negative 3 is greater than 12. Well, negative 3 is not greater than 12. So that's a false statement. And if we have a false statement, remember, we have a no solution. So there aren't any values of b that would make this inequality true. All right, I'm going to erase this one. And now we'll work letter B. So again, we have to distribute through first, and I'm going to get 10w minus 2 is less than or equal to 7 plus 10w. And when I go to solve this and I subtract the 10w from each side, whoops, it happens again. These cancel out. This time I'm left with negative 2 is less than or equal to 7. Well, negative 2 is less than or equal to 7. It's less than. So this is always true. So when the variables eliminate and you're left with a true statement, then your answer is an infinitely many solutions. I'd like you to try these now, and I'll reveal the answers here very shortly. All right, number 5 is just a basic, change size, change signs. We get x is less than or equal to 4. On number 6, if you distribute through, your variables are going to eliminate, and you're going to end up with a true statement. Your true statement is a negative 10 is less than 5, which is true, so your answer is infinitely many solutions. Number 7, if we distribute through, we have negative 12n plus 4 is greater than a negative 12n plus 5.2. And again, the variable terms are going to eliminate. I'm left with a true statement, a false statement, because 4 is not greater than 5.2. So that's a false statement, so then this one is a no solution. And if you work number 8, again, the variables don't eliminate in this case, and our final answer is A is less than or equal to 2. All right, now applying this to a word problem. It says you need a mean score of at least 90 points to advance to the next round of the touchscreen trivia game. What scores in the 5th game will allow you to advance? So we have to be at least, so that's greater than or equal to, a 90. But we have scores of 95, 91, 77, 89, plus our 5th game, which we're going to call N, all divided by 5, that must be greater than or equal to 90. So when I add those scores I already have, that's 352 plus x, all divided by 5, because again, that's how we find the average, or the mean. Now to solve this, because it's the long fraction bar, I'm going to multiply both sides by 5. So now I'm left with 352 plus x is equal to 450. Now I'm going to subtract 352 from each side. And if I do this, I get x is greater than or equal to 98. So to have an average score of a 90, we'd have to score at least a 98 on our last game. So now, what if you need a mean score of 85 points? So again, we have the same equation, 352 plus x, all divided by 5, but now instead of being greater than or equal to 90, it's greater than or equal to 85. So now I'd like you to solve this, give this one a shot, and I'll reveal the answer here in just a moment. And again, if you solve this, you would find that x had to be greater than or equal to a 73. And so you'd have to have a score of at least a 73 if the mean needed to be an 85. And that's all, folks. So that's solving multi-step inequalities, and hopefully you're having a great weekend, and we'll see you on Monday.